Section 1. Introduction to Intersecting Lines. 1. A boy gets up early one morning to go for a long ride on his bicycle. 36 minutes later, his older sister realizes he left the inhaler that he uses for his asthma, so she gets in the car and tries to catch him. Use the graph to estimate what time it is when the older sister catches her brother. Here the graph on the x-axis, horizontal axis, has minutes after 6 a.m., so that is 60 minutes after 6 a.m. We can count the rest of the values on this axis by looking at how many marks there are between here and 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 marks overall, and 60 divided into 10 equal parts is equal to 6 minutes per part. So if this is 0, this is 6, 12, 18, etc. If I kept counting upward, it would be 24, 30, 36. So that makes sense because the sister leaves 36 minutes after her brother. Now let's look at the vertical axis. The label says miles away from home, 10 miles away from home, 20 miles away from home. Let's count more of these values on this axis by looking at how many marks there are. There's 1, 2, 3, 4, 5. So the first 10 miles is split into 5 equal parts. 10 divided by 5 is 2. So this is 2 miles, 4 miles, 6 miles, 8, 10, 12, etc. Now let's look at the two lines. This line represents the boy, and this line represents the sister, because the sister leaves 36 minutes after. 36 minutes after the boy, and the boy leaves at 6 a.m. So this is the girl traveling, this is the boy traveling, and you can see right here is where the girl catches her brother. So I'll put a mark there. If I want to use the graph to estimate what time it is when the older sister catches her brother, I want to look at what time it is at this dot. If I go down, I can see time. It's close to 60 minutes, but a little bit less. And you don't have enough information to know exactly how many minutes that is. So let's say it's about 57 or 58. That's fine. Something close to 60. If it's about 57 or 58 minutes, and that's minutes after 6 a.m., then we can say that the older sister catches her brother around 6:57 or 6:58 a.m. I don't want you to think too much about it. Just put some sort of rough estimate and then keep reading. Looking at the graph, it seems impossible to determine the exact time at which the sister catches up with her brother because the grid lines, which help you determine exact numbers, do not line up nicely at the point where the dashed line intersects the path of the solid line. When you first started graphing points on a Cartesian plane, you learned that there is information contained in each point. Similarly, since lines can be used to represent meaningful values, the intersection of two lines can also contain information. 2. Without using specific numbers, describe the information that is contained in the intersection point of the two lines in the scenario above. The intersection point shows how many minutes after 6 a.m. the sister catches her brother and how many miles they are from home at that moment. In one sense, because you can see the point of intersection, the information that is contained in that point is directly in front of you. For now, though, you can probably only estimate where the two lines intersect. In the scenarios that follow, you will gradually discover how to calculate the exact coordinates of the point where two lines intersect. Number 3. You will eventually learn how to find the exact time that the sister catches her brother, but first consider a simpler example. Looking at the graph shown, where do the two solid lines intersect? Here's one solid line, here's another solid line. The point where they intersect is right here, and that point is shown by the coordinates 1, 2, 3, 1, 2. So 3, 2 is the point where the lines intersect. 4. Where do the two dashed lines intersect? Here's one dashed line, here's another dashed line. The point where they intersect is right here, and the coordinates of that point are -1, 2, 3, 4, and then -1. So -4, -1 is the intersection point of the dashed lines. 5. Your cousin has been working at a company for several months when you join his sales team. At first, you make fewer sales each month than your cousin. Over time, though, you realize you are catching up to him. Part A. How long after you join the sales team will you match your cousin's total monthly sales? Assume you both keep increasing your monthly sales at constant rates. So let's look at the axes and see what they are telling you. This axis says months after you join sales team. So 2 months after you join, 4 months after you join. This axis says total monthly sales in thousands of dollars. So right here is $25,000, and we have 1, 2, 3, 4, 5. So we can add numbers to the scale by realizing that 25 is divided into 5 equal chunks. 25 divided by 5 is 5. So I'll mark 5 here, 10, 15, 20, 25, 30, etc. On the horizontal axis, it's counting by 2s, but there's a mark here and a mark here, so we can fill in those as well by putting a 1 and a 3. So 1, 2, 3, 4, 5, 6, and so on. Now I can look at the dashed line and the solid line. You join after your cousin, and your sales are fewer. So yours is the dashed line because you start off making a lower amount of monthly sales. Your cousin is at a higher amount. But if you can look at the gap here and the gap here and the gap here and the gap here, you can see the gap is getting smaller because you are catching your cousin. So let's continue these lines to see how long it will take for you to match or to catch up to your cousin's total monthly sales. I'll extend these lines. Here's what the lines look like extended, and you can use their slopes to figure out how to extend them. This solid line is going up 1 grid square every time it goes over 1, 2, 3 grid squares. So we can mark a point here, and then it goes up 1 and right 3 again to go to right there. The dashed line is going up 1, right 2, so there's a point, up 1, right 2 again, and then up 1, right 2 again. We can see they intersect right here. So how long is that after you join the sales team? Months after you join sales team. 1, 2, 3, 4, 5, 6. We need to keep counting until we get to this point, which lines up right here. So 6, 7, 8, 9, 10, 11, 12. So we can put 12 months. That's how long it takes for you to match your cousin's total monthly sales. Part B. By what amount do your total sales increase each month? These are your total sales, and they increase from here to here by, well, let's go from 10 to 20. That's an increase of $10,000 every how many months? 1, 2, 3, 4. So that's increasing by 4 months, increasing by $10,000 every 4 months. Up 10,000, right 4 months. So let's write that as a rate, $10,000 per 4 months. To convert that to a sales rate each month, I can do 10,000 divided by 4, and that gives me the amount per 1 month. That's $2,500 per month. Part C. What are your total monthly sales during the month that you catch your cousin? Here's the point where you catch your cousin. We know it's after 12 months. Well, we can take this point and slide across to the vertical axis to figure out your total monthly sales. What's that value? We were counting up by 5s, 5, 10, 15, 20, 25, 30, 35, 40. So this is 40, and we want to be careful not to put $40. It's in thousands of dollars, so that's $40,000. 6. To refresh your familiarity with graphing lines, prove that the following lines intersect at -2, -5 by graphing them. Equation 1, y equals 3x plus 1. 3 is the slope, and 1 is the y-intercept. Let's plot the y-intercept first at 0, 1, and then use the slope, 3 over 1, to plot more points. The rise is 3 and the run is 1. They're both positive. So from this red dot, you can count up 3, 1, 2, 3, right 1, and put a dot right there. You can go up 3, right 1, and put another dot. You can go down 3, left 1, and reverse that to put another point going the other direction, and then go down 3, left 1 as well. And now that I have those points drawn, I can easily draw a line through them. That's the line y equals 3x plus 1. Equation number 2. Y equals -1/2 x minus 6. So the slope is -1/2 and the y-intercept is -6. I'll start by plotting the y-intercept first. 0, -6. So start at 0, 0, and then go down 6. 1, 2, 3, 4, 5, 6. There's my point. Now I can use the slope of -1/2. That's either -1 over +2 or +1 over -2. So from this y-intercept, we can go down 1, right 2. Now we're off the grid, so we can switch that and go up 1, left 2. Up 1, left 2, up 1, left 2. There's the line passing through those points. And finally, let's confirm that the two lines intersect at -2, -5. There's the point, and it is in fact negative 2, comma, negative 5. So we have reviewed graphing, and we're seeing that lines can intersect. In a previous lesson, you learned how to determine the equation of a line when you can see its graph. However, even though you were comfortable with this at one point, it may be buried in your memories right now. Venture back into this topic by working through the next scenario. 7. Although there are various forms that you can use when you write the equation of a line, like standard form and point-slope form, write your equation in slope-intercept form for now. What is the slope-intercept form for the equation of a line? That would be y equals mx plus b. M represents the slope, and b represents the y-intercept. That's why it's called the slope-intercept form. 8. Determine the equation of each line shown. Let's write the equation in slope-intercept form. Y equals mx plus b. Part A, this is the line. Let's start by locating the y-intercept. It's 1, 2 above the x-axis, so its coordinates are 0, 2, so b equals 2. Now I'm going to find the slope using 2 points. I'll mark this point here and this point here. From the left to the right, I would go up 2 units and then right 5 units. So the slope is 2/5, and that equals m if we're using y equals mx plus b. Now I can write the equation of the line as y equals 2/5 x plus 2. Part B. Here's the line. Let's locate the y-intercept first. There's the y-intercept. It's located at 0, 0. Since it's 0, 0, I can write that b is equal to 0. Now I'll mark 2 points to find the slope. Here's a point up here, and here's a point. To go from the left point to the right, I go down 3, and then right 2. So the rise over run is negative 3 over positive 2. So m is negative 3/2. I can now write the equation as y equals negative 3/2 x plus 0. Plus 0 doesn't change anything, so I can leave it out. Y equals negative 3/2 x. Number 9, determine the equation of each line shown. Part A. This line is called a horizontal line, and every point, no matter where you stop on this line, has the same y value. This point is 0, 3. This point is 4, 3. This is negative 4, 3. No matter where you stop on the line, the y value is always equal to 3, and that is the equation of the line. A horizontal line's equation is always y equals a number because the y value is always one specific number on a horizontal line. Part B. This is a vertical line, and as you might guess from the previous one, anywhere we stop on this line, the x value is always the same. This point is negative 4, 0. This point is negative 4, 3. This point is negative 4, negative 4. Every point on this line has the same x value. X is always equal to negative 4. And a vertical line's equation is always going to be x equals a number because the x value is the same at every point on a vertical line. 10. It will be helpful later on to make sure that you are familiar with replacing variables in equations with specific numbers. Consider the equation y equals 2x plus 1. A. If the value of x is 0, then the value of y is 2 times 0 plus 1, or 2 times 0 is 0, 0 plus 1 is 1. Part B. If the value of x is 1, then y is, well, let's write the equation. Y equals 2 times the value of x is now 1, plus 1. 2 times 1 is 2, so y equals 2 plus 1. 2 plus 1 is 3, so y equals 3. Part C. If x is 2, then y equals, now we're going to write the equation, y equals 2x plus 1, but we will replace x with 2. 2 times 2 is 4, so y equals 4 plus 1. 4 plus 1 is 5. So y equals 5. Part D. If y equals 2, then x equals, let me write the equation, y equals 2x plus 1. I'm replacing y with 2 now, so I'll put a 2 right there. I can solve for x by subtracting 1. 2 minus 1 is 1, so 1 equals 2x. Let me rewrite that over here. If 1 equals 2x, then I can divide both sides by 2 to see that the value of x is 1/2. So x is 1/2, or 0.5. Number 11. Now consider the equation y equals 1/4 x plus 2. A. What is the value of y if x equals 4? Let's write the equation. Y equals 1/4 times the x value plus 2. Now I'm putting an x value of 4. 1/4 times 4. 1/4 of 4 is 1. So y is equal to 1 plus 2. And 1 plus 2 is 3. If x equals 4, y equals 3. Part B. What is the value of x if y equals negative 2? So now I'm solving for x, given that y is negative 2. The equation is y equals, so I'm going to replace y with negative 2. Now the equation is negative 2 equals 1/4 times the x value plus 2. Let's solve for x. Subtract 2 from both sides. Negative 2 minus 2 is negative 4. Negative 4 is equal to 1/4 of what number? If I don't know, I can undo multiplying by 1/4 by multiplying both sides by the reciprocal of 1/4, which is 4. Multiply the left side by 4. 4 times negative 4 is negative 16. So negative 16 is equal to x. If x is negative 16, then y will equal negative 2. Moving on to part C, which is on the next page. What is the y value if x equals 1/2? Write the result as a fraction and as a decimal. X equals 1/2. Let's write the equation. Y equals 1/4 x plus 2. I can replace x with 1/2. 1/4 times 1/2 equals 1/8. So y equals 1/8 plus 2. That's 2 and 1/8. If I want to write that as a fraction, I can write it as an improper fraction. Well, 2 is 16/8. So this is really 16/8 plus 1/8, or 17/8. That is 2 and 1/8 as a fraction. As a decimal, you can use a calculator and do 17 divided by 8. That's 2.125. If you want to do this without a calculator, you would need to know that 1/8 is half of 1/4, and 1/4 is 0.25. So if 1/4 equals 0.25, if you want to take half of that, you can think about what's half of 25. Half of 25 is 12.5. Half of 0.25 is 0.125. So you can realize that if 1/8 is 0.125, then 2 and 1/8 is 2.125. So we can write this value as an improper fraction, as a decimal, and this original form we had is the mixed number. 12. For the equation y equals negative 2/3 x minus 4, what is the value of y if x equals negative 9/4? Let me write the equation. Y equals negative 2/3 times the x value, and that's negative 9/4 minus 4. 2/3 times negative 9/4. I'll do that over here. 2 over 3 times 9 over 4. You can cancel out some disguised forms of 1 first before you multiply these. 3 divides into 9 3 times, so I can put a 1 down here and a 3 up there. 2/4 is the fraction 1/2, because 2 and 4 are both divisible by 2. Now I can multiply 1 times 3 on the top, and then 1 times 2 on the bottom, and see that it's 3/2. So I can go back to this and write y equals 3/2 minus 4. If I'm going to do this without a calculator, I can write 3/2 minus 4 over 1, and change 4 over 1 to something with a denominator of 2. I can do that by multiplying the top and the bottom by 2. So I get 3/2 minus 8/2. 4 is 8 over 2. 3/2 minus 8/2 is 3 minus 8 over 2, which is negative 5 over 2. If I wanted to write that as a decimal, that's a negative 2.5. If I wanted to write it as a mixed number, it's negative 2.5. These are 3 ways to express the same value. 13. For the equation y equals negative 4/5 x plus 1, what is the value of y if x equals 3 3/4? The equation is y equals negative 4/5 times the x value plus 1. If I let x be 3 3/4, it will be very hard for me to multiply it by 4/5. So let's convert 3 3/4 to an improper fraction. 3 as a whole number is 12/4. So 3 3/4 is 12/4 plus 3/4, or 15/4. That's the value I'm going to replace x with in these parentheses. 4/5 times 15/4. I can multiply the top and the bottom numbers, but I can also cancel disguised forms of 1 first. 4 over 4 is equal to 1, and 5 divides into 15 3 times. So I can reduce the numbers that I'm working with. Negative 1 times 3 is negative 3. and that's negative 3 over 1, so just negative 3. Then bring down the plus 1. Now I have y equals negative 3 plus 1, or y equals negative 2. 14. Each equation below is written in standard form, ax plus by equals c. Rearrange the equation to write it in slope-intercept form, y equals mx plus b. Standard form has x and y, or the variables, on the same side. Slope-intercept form has y isolated. In part A, we can isolate y by moving the 3x. 3x is positive, so we'll subtract 3x from both sides. 3x minus 3x is 0, so I have y equals 7 minus 3x. If I want to be very rigid with my definition of slope-intercept form, I want the x term to come first, so I'll write y equals negative 3x first, and then the 7 comes next, and it's positive, so we will write plus 7. So negative 3x plus 7. Part B, 3x minus y equals 7. I want to get y by itself, so I'm going to move the 3x. It's positive, so I'll subtract 3x again. Now I need to bring down a minus y and negative y, the opposite of y. That is equal to 7 minus 3x. I could move the order around and put negative 3x first, and then a positive 7 or plus 7 next, and then I have a negative y. To change the negative y to a positive y, I can do two things. I can divide by negative 1, or I can multiply both sides by negative 1. I'll divide both sides by negative 1, and divide both of these terms by negative 1. Negative y divided by negative 1 is positive y. Negative 3x over negative 1 is positive 3x. And then plus 7 divided by negative 1 is a minus 7. So y equals 3x minus 7 is the slope-intercept form. 15. Rearrange the equation to write it in slope-intercept form. 4x minus 5y equals 10. Let's move the 4x first. It's positive, so I will subtract 4x from both sides. Bring down the minus 5y, or a negative 5y. 10 minus 4x is on the right side. I can divide both sides by negative 5. I could also switch the terms 4x and 10, but I'm going to leave them in that order for now and just divide both sides by negative 5 to show you how to approach it that way. On the left side I have y equals, and on the right side I have two terms both divided by negative 5. If it helps you, let's write it out as separate terms divided by negative 5. Let's write 10 over negative 5, and then minus 4x over negative 5. 10 over negative 5, or 10 divided by negative 5, is negative 2, and then I can write minus. 4 over negative 5 can't be reduced, it's just a negative fraction because the bottom is negative while the top is positive, so I can write negative 4/5 x. Since I have a minus, a negative, those combine to form addition, so I'll write it as y equals negative 2 plus 4/5 x. And then lastly, to get it into slope-intercept form, we'll put the x term first. It's a positive 4/5, so I'll write y equals 4/5 x, and the 2 is negative, so I'll write minus 2. There's your slope-intercept form. 16. Is the slope of the line shown positive or negative? This line going from left to right is going downhill, so if you read it from left to right and it's going downhill, that means the slope of the line will be negative. In part B, this is a horizontal line. Between any 2 points on this line, such as these 2 points, there is no rise. There's only a run. So if you write rise over run as a fraction, the rise is 0 and the run is some value. 0 divided by some number is equal to 0. This doesn't have a positive slope. This doesn't have a negative slope. So we would write neither. This slope is 0. Part C. The line going from left to right is slanting upward, so it has a positive slope. I'm asking you to think about whether lines are negative in their slope or positive in their slope, because sometimes you will calculate the slope and you'll make a mathematical mistake. But if you look at a line like this and you get a positive slope, you should be able to determine that you made a mistake because you know this line has to be negative. My calculations showed me it's positive. Let me go back and check my work to see if I have made a mistake that I can identify.